Welcome to the Explainer. Go ahead, grab a coffee, and pull up a chair. I'm going to be your senior lead engineer for today, and you can consider this our one-on-one code review session. Now, if you've been building applications for a little while, you've probably got the basics down, right? Getting a server up and running? No problem. But today we're doing a deep dive. I want to take those Spring Boot skills, pop open the hood, and really level you up to that senior mindset.
Okay, let's get real for a second and dive into a situation I know you've experienced. Why does your code work perfectly on your local machine, with your nice, tiny little test database, but then absolutely crawl the second we deploy it to production? Trust me, it is a total rite of passage for every junior developer to run into this exact wall. But today, we are upgrading your whole approach. We're moving away from simply making it work to actually making it scale. Here is our roadmap for today's review. We're going to cover JPA performance, smarter testing using test slices, microservices tracing, and finally, the magic of Spring Boot 3 virtual threads.
All right, Section 1, the magic of transactions. Let's start with the absolute bedrock of any robust backend application, the database layer. Now, before we even look at a single line of code, we got to touch on the theory, the ACID properties: atomicity, consistency, isolation, and durability. These are your core principles for reliable database transactions. Without these, a random mid-process crash or a tiny network hiccup could leave your database in a completely corrupted, half-updated mess. And trying to handle this manually, oh man, it requires so much boilerplate code. You're opening connections, committing them, writing endless catch blocks, manually closing them. It's a headache.
But luckily, Spring Boot gives us an incredibly powerful shortcut here. Think of the @transactional annotation as literally a giant undo button for your database operations. If your method runs perfectly, Spring automatically commits the changes to the database. Simple. But if an exception gets thrown anywhere in that process, Spring just hits that undo button and automatically rolls back the entire transaction. It keeps your data completely safe. You can slap it on a method or a whole class, and it even supports complex propagation behaviors, like if you explicitly need to spin up a new independent transaction for a specific piece of logic. Moving right along, Section 2, avoiding JPA performance traps.
Look, object relational mapping is fantastic for developer velocity, but man, it is so easy to accidentally misuse. Actually, this is by far the most common area where I spot production bottlenecks during code reviews. Fixing performance issues always starts with one golden rule: actually seeing what's happening under the hood. You literally can't fix a query you can't see. So step 1 for your local development environment, set generate_statistics to true in your application properties. Step 2, activate debug logging for your Hibernate stats and SQL statements. Once you do that, you can watch exactly what Hibernate is running behind the scenes. You'd be amazed how quickly you'll notice if one innocent little Java method call is accidentally firing off 50 different database queries. And that brings us straight to our first rookie mistake. I see this all the time, calling save and flush for every single entity update. The senior fix here? Just let the persistence context do its job and auto-flush your managed entities. See, when you fetch an entity from the database, it's already in a managed state. Hibernate is actively tracking your changes to that object, and it will automatically generate the right update statements when the transaction finally commits. Forcing a flush manually? It just creates totally unnecessary database overhead and slows your app down for no real benefit. Just trust the JPA lifecycle. Okay, here's another huge trap: using GenerationType.auto for your primary keys. If your underlying database doesn't support sequences natively, this seemingly harmless setting actually falls back to a highly inefficient table strategy. It literally uses a whole separate database table and pessimistic locks just to generate your IDs. Under heavy load, that will absolutely crush your application's scalability. So, the senior fix is to explicitly define your strategy. If your database supports it, always use GenerationType.sequence. This lets Hibernate fetch IDs in batches, like say 50 at a time, which drastically reduces the number of database calls you need just to insert new records. Now, let's talk about the absolute most notorious performance killer in Spring Boot, the N+1 select issue. This happens when you use fetch type eager on your database associations. You fetch one record, and Hibernate immediately panics and fetches all the related records, causing this massive, unexpected cascade of unwanted queries.
The senior fix? Set all your too many and too one associations to fetch type lazy. Just delay fetching that extra data until you literally need it in the code. And when you do finally need it, define exactly what you want using an @entity graph annotation or write a custom join fetch query so you grab everything in one single, highly efficient trip to the database.
All right, Section 3, Smarter Spring Boot Testing. Let's shift gears away from the database and look at your CI/CD pipeline, because right now, I know your test suite is taking way too long to run. Here is the absolutely crucial takeaway. Stop booting the whole app for every single test. When you use the standard @Spring Boot test annotation, it loads your entire application context, database connections, external APIs, security filters, the whole shebang. That's fine for an end-to-end integration test, sure, but it is massive overkill for a simple unit test. You need to use test slices instead. Use @WebMVC-test to spin up just your web layer for your controllers. Use @DataJPA-test to test just your repositories. Use @MockBean to easily swap out external dependencies. Slicing it up like this makes your feedback loop lightning fast. To put it as simply as possible, you don't need the whole car to test the radio, right? By isolating your layers, you test exactly what you want without carrying all that extra baggage. Take @DataJPA-test, for example. Spring will actually auto-configure a lightweight, in-memory H2 database just for you. Verify your custom queries, and then cleanly roll back all the changes after each test. It's clean, it's fast, and it is beautifully isolated. Moving on, Section 4, Debugging Distributed Microservices. Let's zoom out a bit and look at the big picture architecture. We all know that monolithic scaling wastes resources, which is exactly why the industry shifted to microservices. But let's be real, that modern standard comes with some serious headaches. We've all been there. You push your shiny new code, it passes the pipeline, you go grab a coffee to celebrate, and suddenly a completely different service on the other side of the system just breaks. Trying to track down a cascading exception across 4 different microservices by staring at scattered console logs, it's a total nightmare. And that is exactly why we need centralized observability. Enter tools like Zipkin or Micrometer Distributed Tracing in modern Spring Boot 3. These systems are absolute lifesavers. They assign a unique trace ID to a request the exact moment it enters your architecture, and then they track that ID as it hops from service to service. It records latency, and if an exception pops up, it pinpoints exactly which microservice is the bottleneck or the culprit. No more guessing games. You get a perfectly clear visual map of your request's entire journey. Finally, Section 5, Scaling with Spring Boot 3. As your mentor, I really want you looking toward the future of your career. And right now, that means tapping into the absolute newest performance features available. And there's one single configuration property that literally changes everything. Spring.threads.virtual.enabled equals true. Just flipping this one switch unlocks the incredible power of JDK21 virtual threads, leaving our old clunky limitations completely behind. Because for years, we've been bound by the limits of heavy, expensive OS threads. If an OS thread had to wait for a database query to return, it just sat there, totally blocked, wasting your precious server resources. So what's the result of flipping that single property? 10,000 plus. That is the number of concurrent requests your Tomcat server can now effortlessly handle using virtual threads. Before this, you'd probably max out around 200 concurrent requests before your server started choking and rejecting connections. It's wild. Virtual threads are cheap, they're lightweight, and when they hit a blocking I/O operation, they just politely yield the underlying OS thread to go do other work. It is an absolute game changer for high concurrency apps. And hey, that's not all. Spring Boot 3 brings a whole host of other developer experience upgrades you really should be using. We've got the REST client now, which is a modern, fluent alternative to that old, clunky REST template. We have the GDBC client, which makes native database access super simple without all the verbosity of the old JDBC template. And my personal favorite, @Service Connection. It automatically configures your test containers, like PostgreSQL or Redis, which completely eliminates a ton of annoying boilerplate configuration code in your integration tests. All right, let's wrap up this code review with a quote that I think perfectly nails the reality of our industry. You can solve 80% of your issues with Spring Boot. Those 20% is where the pain will be. The framework does a massive amount of heavy lifting for you, and that easily gets you 80% of the way there. But mastering these under-the-hood details, the JP lifecycles, the transaction boundaries, the test slices, the thread models, that is exactly how you solve that painful 20% and truly become a senior engineer. we've covered a ton of ground today, right? From finally stopping that N+1 select problem, to slicing up your test suite, to unlocking the pure magic of virtual threads. So I'm going to leave you with one final question to chew on. Are you ready for your next pull request? I want you to take these senior level concepts, apply them to your code right now, and let's see just how much faster and cleaner we can make this application. Thanks so much for joining me in this explainer, and happy coding.